graph. How to graph linear equations with a restricted domain. What is it? A diagram of values usually shown as lines. Why? Helps to show tendencies to predict the future. Interesting fact. To avoid being attacked by predators, beetle species have many strategies, such as camouflage, toxic properties, and fighting defenses. Now let's take a look at the examples we're going to be talking about in today's video. And let's take a closer look at example 1. Let's read the steps. Step 1, pick the limits as the inputs. Step 2, find the outputs. Step 3, plot the points and connect them. Let's read the question. Graph the given equation y is equal to negative x minus 2 for negative 1 less than or equal to x less than or equal to 1. Now you may be wondering, what are the values of x, or our input value is going to be? Well, normally you can pick any one, but in this case we have to pick the restricted values or the limits that we have on the equation, and those two numbers are negative 1 and 1. Now I would recommend doing 3 points, because sometimes when you only do 2 you don't realize you made a mistake, and if you do 3 points and you draw your line and your line goes through all of them, then you know you did it correctly. So that's why we're going to do 3 points, and the third point has to be in between the 2 points of negative 1 and 1, and we're going to pick 0 because 0 is a small number and one of the easier numbers to substitute into any equation. So now let's go ahead and start showing the work. Let's rewrite the equation. Y is equal to negative x minus 2. Now we're going to substitute the first value of x, and that is negative 1. So we have y is equal to negative times the parentheses of negative 1 minus 2, and we multiply negative times the negative 1, then you get positive 1, because when you multiply two negative numbers they become positive. So you have 1 minus 2, and the result of that is negative 1. We put that value into the table because it is the output or the y value, and now we have the point negative 1, negative 1. And we plot that point. As you can see, the point is filled in, and the reason for that is because if we look at the symbol in between negative 1 and x, it says less than or equal to. Since it says equal to, we want to show that that point is a part of the graph, and to show that, we fill in the point. In other words, you can kind of think about it, we want more of it. Since we want more of it, we're going to fill it in. Let's take a look at the next input value, and that is 0. Let's go ahead and substitute that into the equation. So we have negative times the parentheses of 0 minus 2, and negative times the parentheses of 0 is 0. So now we have 0 minus 2, and 0 minus 2 is negative 2. Put that value into the table, and now we have the point 0, negative 2. We plot that point. As you can see, the point is filled in, and the reason for that is because the input value of 0 is in between your 2 points of negative 1 and 1. Any input value that is in between the two restricted values is going to be a part of the graph. So let's go ahead and take a look at the last input value, which is 1. So we substitute that into the equation. So now we have negative times the parentheses of 1 minus 2, and negative times the parentheses of 1 is just negative 1. So now we have negative 1 minus 2, and that gives us negative 3. Put that value into the table, plot the point 1, negative 3, and it's filled in, because if you look at the symbol between x and 1, it says less than or equal to. Since it says equal to, we want the result to be a part of the graph, and to show that, we fill in the point. And now let's get rid of the work. Let's focus on the graph. Now since we have 3 points, we know our two endpoints. Let's go ahead and draw the line. So the line goes through all 3 points. We know we did it correctly, and this line does not have any arrows, just because we have 2 endpoints. So let's take a look at example 2, where we have y is equal to 2x minus 3 for 0 less than or equal to x less than 4. So we're going to go ahead and pick 2 input values, and there will be 0 and 4. because once again the restricted values or the limits on our equation are given to us, so we have to use those two input values. Now let's pick a point in between 0 and 4. Let's pick 1 because it's one of the smallest numbers you can pick. Now let's go ahead and start showing our work. Let's rewrite the equation. Y is equal to 2x minus 3. Let's substitute the first value of x, and that is 0. So now we have 2 times 0 minus 3, and 2 times 0 is 0. Now we have 0 minus 3, and that gives us negative 3. Put that value into the table. We now have the point 0, negative 3. Let's go ahead and plot that point. We know the point is filled in because if you look at the symbol between 0 and x, it says less than or equal to. Since it says equal to, we want that point to be a part of the graph, and we fill it in. Let's move on to the next input value, and that is 1. So we substitute 1 into the equation. So now we have 2 times 1 minus 3, and 2 times 1 is 2. So now we have 2 minus 3, and the result of that is negative 1. Put that value into the table, and now we have the point 1, negative 1. Let's go ahead and plot that. As you can see, the point is filled in because the input value of 1 is in between the restricted values or the limits we have of 0 and 4. Now let's move on to the last input value of 4. So we substitute that in. So now we have 2 times 4 minus 3, and 2 times 4 is 8. So now we have 8 minus 3, and the result of that is 5. So we plug it into the table. We have the 0.45. As you can see, the point is not filled in. And the reason why it's not filled in, because if you look at the symbol between x and 4, it says less than. Since it says only less than, we do not fill it in because we want to show that that point is not a part of the graph. Since we want to show that, we need to leave our point blank or not filled in, but we still have it because we want to show where the graph ends. Now let's go ahead and get rid of our work. Let's connect the dots, and as you can see, it went through all 3 points, so we know we did it correctly. Now let's take a look at example 3, where we have y is equal to 1/2 x minus 1 for negative 2 less than x less than or equal to 4. And we know there's 2 points already that we have to choose because they are the restricted values or the limits we have on the equation, which are negative 2 and 4. So let's pick a point in between negative 2 and 4, 0. Now we have our 3 input values. Let's start to show our work. Let's write the equation down. Y is equal to 1/2 x minus 1. Let's substitute the first value of x that we have, which is negative 2. So now we have 1/2 times negative 2 minus 1, and 1/2 times negative 2 is negative 1. Now we have negative 1 minus 1, and the result of that is negative 2. So that output, or that value of y, now goes into our table, and now we have negative 2 as our first point to graph. Let's go ahead and plot it. As you can see, our point is not filled in, and the reason for that is because if you look at the symbol in between negative 2 and x, it says less than. Since it does not say equal to anywhere for that symbol, we're not going to fill it in because we want to show where the graph ends or starts. In this case, it starts. Okay, so now we can go ahead and start working on the next input value, which is 0. Substitute that in. So now we have 1/2 times 0 minus 1. Now 1/2 times 0 is 0. So now we have 0 minus 1, and the result of that is negative 1. Put that value into the table. So now we have the point 0, negative 1. As you can see, our point is filled in because once again, our input value of 0 is in between the 2 restricted values or the 2 limits that we have for our equation. Now let's take a look at the last input value for this equation, which is 4. Substitute 4 into the equation. Now we have 1/2 times 4 minus 1, and 1/2 times 4 is 2. And now we have 2 minus 1, and the result of that is 1. Put that value into the table. So now we have the point 4, 1. Let's go ahead and plot the point. As you can see, the point is filled in, and the reason for that, because if we look at the symbol between x and 4, it says less than or equal to. Since it has equal to, we want the result to be a part of the graph, and to show that, we fill in the point. Now let's get rid of the work. Let's connect the dots or the points, and the line goes through all 3 points. We know we did it correctly, and once again, we don't have any arrows because we have 2 restricted values or 2 limits on our equation. Now let's take a look at example 4, where we have y is equal to negative 2x minus 1 for negative 1 less than x less than 2. So we know our two points are 2 input values or 2 values of x that we need to choose because they are restricted values or the limits that we have on the equation, and those are negative 1 and 2. Now let's go ahead and pick a value in between negative 1 and 2. And in this case, we're going to pick 1 because why not? So let's go ahead and start showing our work. Let's rewrite the equation. Y is equal to negative 2x minus 1. Let's substitute negative 1 into the equation. So now we have negative 2 times negative 1 minus 1. And negative 2 times negative 1 is positive 2, because when you multiply two negative numbers, they become positive. So now we have 2 minus 1, and the result of that is 1. Put that value into the table. So now we have the point negative 1, 1. Let's go ahead and plot that. As you can see, the point is not filled in, because if you look at the symbol between negative 1 and x, it says less than. Since it only says less than, we do not fill it in, because we want to show on the graph that we know where the endpoint is. What we know that it is not a part of the answer. And to show that, we don't fill in the circle. So let's move on to the next input value, and that is a 1. Substitute 1 into the equation for the variable x. So now we have negative 2 times 1 minus 1. And negative 2 times 1 is negative 2. Now we have negative 2 minus 1, and that gives us negative 3. Put that value into the table. Now we have the point 1, negative 3. Let's go ahead and plot that point. As you can see, the point is filled in, and the reason why is because our input value 1 is in between our 2 restricted values, or between the 2 limits that we have on the equation. Let's take a look at our last input value, which is 2. Let's go ahead and substitute 2 into the variable x. So now we have negative 2 times 2 minus 1. And the result of negative 2 times 2 is negative 4. So now we have negative 4 minus 1. And the result of that is negative 5. So we plug that value into the table. We have our point 2, negative 5. Let's go ahead and graph that point. As you can see, it is not filled in. And the reason for that is because the symbol between x and 2 is less than. Since it doesn't say less than or equal to, we're not going to fill it in. And the reason why we don't fill it in is we want to show where the graph ends, but we want to show that that value is not a part of our answer set. Now let's get rid of the work. Draw our line on the graph. That line goes through all the 3 points, so we know we did it correctly. And there we have it. Now, it is your turn, so go ahead and pause the video so you can take your time to answer this question, and I will show you the answer in 3, 2, and 1. Here are the answers. If you got them correct, well done. If you didn't, there's always tomorrow.